Hello students, welcome to Anne's classes. Let's do squares and square roots, test yourself. This is found on page number 50. The multiple choice type. Choose the correct answer from the options given below. First one, a Pythagorean triplet has one number equal to 6. So the Pythagorean triplets are in this. Okay, so there are three options given to us and they're saying one number is equal to 6. So we have 6 here, 6 here, 6 here and 6 here. And all four options we have 6. Now, which of these four options forms the Pythagorean triplet? Okay, so we have to find out. One way is a normal way of doing a square plus b square equals c square. That is, the square of 5 plus the square of 6 should be equal to square of 7. Now we can just take that, the first example here. So 5 square plus 6 square should be equal to 7 square. 5 fives are 25, 6 6 are 36. Now this should be equal to 49. Now 25 plus 36 is 61 and it is not equal to 49. So this option A, they cannot form triplets. So these numbers 5, 6 and 7 cannot form Pythagorean triplets. They are not triplets. Now that is one way of finding out. Another way is there is a formula and the formula is this. 2m is one number, m square minus 1 is another number, m square plus 1 is another number. Now I'll work this out and show you. So here they're saying one number is equal to 6. So the first number 2m, we'll take it as 6. So this is how it is. 2m is equal to 6. That means m will be equal to 6 divided by 2. 6 divided by 2 is 3. So m is equal to 3. So we've got our first number. We said 2m is 6. And now we know m is 3. So now we're going to find out m square minus 1. M is 3. So m square means 3 square minus 1. 3 square is 3 threes are 9 minus 1, which is 8. So we've got our second number, which is 8. So let's write 8 here. Then we have m square plus 1. M square plus 1. So m square means 3 square. 3 square plus 1. 3 square is 3 threes are 9 plus 1, which is 10. So we've got our third number and that is 10. So these three numbers, that is 6, 8 and 10, form the Pythagorean triplet. And we have it here 6, 8 and 10. So our answer is option D, 6, 8 and 10. So one way is you can do it this way. Take the biggest number and that should be equal to the sum of the squares of the other two numbers. So 5 square plus 6 square should be equal to 7 square. Here 6 square plus 7 square should be equal to 8 square. Here 4 square plus 6 square should be equal to 8 square. Only if they're equal, then we call them the Pythagorean triplets. So if you see in all these four, only here you will see that 6 square plus 8 square is equal to 10 square. Let's see that. Let's work that out. 6 square plus 8 square should be equal to 10 square. 6 6s are 36. 8 8s are 64. How much is this? 36 plus 64 is 100. And on the other side, 10 square. 10 10s are 100. Can you see they're equal to each other? That's why 6, 8 and 10 are called the Pythagorean triplets. So this is one way of doing it. This is the other way of doing it using the formula. Question 2. The number of digits in the square root of this number. Okay. Now when you are given a large number and you are asked to find the number of digits in the square root of that number, the first thing you need to do is count the number of digits. So let's count the number of digits. 1, 2, 3, 4, 5, 6, 7. So there are 7 digits. That means this is an odd number. So now there is a formula. The formula is to find the number of digits in the square root of a number, you have to say number of digits, that is 7 divided by 2 if n is an even number. That means n is this. So 7 is not an even number, so this formula is not applied here. Instead, if it is an odd number, there is another formula, that is number of digits, which is n, that is 7 plus 1 divided by 2 whenever n is an odd number. So the first thing you need to do is count the number of digits, see whether it's odd or even number. If it is an odd number, apply this formula. If it is an even number, use this formula. So now we're going to use this formula. Number of digits, that is how many digits are there? There are 7 digits we counted, plus 1. Number of digits plus 1 divided by 2. So 7 plus 1 is 8. 8 divided by 2. 2 fours are 8. When you divide 8 by 2, you get 4. So that means there are 4 digits in the square root of this number. So let's look for the option. Option is B, and the answer here is 4. Question 3. The greatest 3-digit perfect square number is. So we have to find out which of these is the greatest 3-digit perfect square number. So first, which is the greatest 3-digit number? 999, isn't it? This is the greatest 3-digit number. Now we're going to find the square root first of this number. So here let's find out the square root of 999. Now we pair the numbers here from right to left. Now we have 3 left here, so we're going to start 3. 3's are 9 minus 0. We bring down the next pair, that is 99. We write the double of 3. 3 2's are 6. And we write a number here next to 6 and multiply with that to get a number close to 99. So here 6, we have 6. Now let's write 1 here into 1. 61 into 1 is 61. We have to write that itself. So here let's write 1 into 1 is 61 minus. Now 9 minus 1 is 8 and 9 minus 6 is 3. Now we have 38. So the remainder is 38. That means we know that this number is not a perfect square. So what we're going to do is we're going to take the highest number 999 and subtract the remainder from it. So 999 subtract the remainder 38. Let's see, 9 minus 8 is 1. 9 minus 3 is 6 and 9. Now we have a number which is a perfect square. So we found the square root of 99. We found that there is a remainder, and that remainder, when we subtracted from 999, we got a number which is a perfect square. So here look out for that number 961, which is option B. So this is our answer, option B, 961. The greatest 3-digit perfect square number is 961, and that is there in our options. So that is our answer. Question 4. The area of a square plot is 441 meters square. Its perimeter is one of these. So area is given to us, we have to find its perimeter. So whenever area is given and we have to find its perimeter, we have to use this formula. Perimeter of a square is 4 root area. Okay, that is A stands for area here. So right, that is 4 into the square root of area. So that will be 4 into the square root of area, and area is given to us as 441 meter square. So 4 into, now the square root of 441 is 21. So you can find out using the prime factor method, or you can use the division method and find out square root is 21. Now 4 into 21 is 84. And since we are finding the perimeter, our unit is only meters. So 84 meters is our answer, and that is option B. Option B is 84 meters. Question 5. Express 21 square as the sum of two consecutive whole numbers. Okay, so 21 square, we have to write it as the sum of, that means we have to add up two consecutive numbers. That means they should come one after the other. So when you add up two numbers, two whole numbers, answer should be 21 square. So let the first number be x. So the second number will be x plus 1, because we are talking about consecutive numbers, numbers that come one after the other, like 5 and 6 are consecutive numbers, 9 and 10 are consecutive numbers. So two numbers that come one after the other are called consecutive numbers. So here let the first number be x. So the second number will be x plus 1. Okay. And we also know that 21 square is 441. This you have to find out by multiplying 21 into 21 is 441. Now we are asked to write 21 square as the sum of these, isn't it? So x plus 1 is equal to 441. So if you add up x and x plus 1, both the numbers, you will get 441. So now let's solve for x. Let's find out the value of x. X plus x is 2x. 2x plus 1 is equal to 441. That means 2x is equal to 441 minus 1, because I've transposed this plus 1 to the other side, it has become minus 1. So now we have got the value of 2x. 2x is equal to 440. Now let's find the value of x. X is equal to 440 divided by 2. Now 2 2s are 4, 2 2s are 4, 2 zeros are 0. So we have found the value of x to be 220. So x is 220. That means, look at this. We said let the first number be x, and we found out x to be 220. So the second number will be x plus 1. That means 220 plus 1, which is 221. So we have got our answers. 21 square is 220 plus 221. So answer is 220 plus 221. It will give us 441, which is the square of 21. Question 6. Find the square root of 1086 by 121 by the prime factor method. So first step is we convert this to an improper fraction. So 121 into 10. That's the first step. 121 into 10, we get 1210. Then we add 86 to it. So let's add this up. So here we get 6, 9, 2, 1296. That means we're going to find the square root of 1296 by 121. And the method we're going to use is the prime factor method. So first let's find the square root of 1296. So prime factor method, let's write down the number 1296. We're going to divide this by 2. 2 6s are 12. Then we take 9. 2 4s are 8. There's 1 left. 16. 2 8s are 16. We continue. 2 3s are 6. 2 2s are 4. 2 4s are 8. Continue again by 2. 2 1s are 2. There's 1 left. 12. 2 6s are 12. 2 2s are 4. Again by 2. 2 8s are 16. 2 1s are 2. Now we use 3. 3 2s are 6. 7 8. There's 2 left. So 21. 3 7s are 21. Continue. 3 9s are 27. 3 3s are 9. And 3 1s are 3. So now we have all our factors here, and now we're going to pair them up. Okay, so before that we're going to write it down here. So this will be the square root of, now we write down all these 2's. Let's count the 2's. 1, 2, 3, 4 2's. There are 4 2's. So 1, 2, 3, 4. And how many 3's are there? We have 1, 2, 3, 4 3's. So let's write that into 3 into 3 into 3 into 3. Now 121, the square root of that is 11. That means 11 into 11. Now we're going to pair them up. So here we have one pair, 1, and then again we have a pair, and we have here. Now we're going to remove the square root sign and take one number from each pair. So we have 2 into 2 into 3 into 3. So we have taken 1 from each pair, and in the denominator 1 from that pair, so that is 11. Now let's multiply. 2 2's are 4, 4 3's are 12, 12 3's are 36. So this is 36 by 11. So this is an improper fraction. Let's convert it to a mixed number. 11 3's are 33. What is left? 34, 35, 36, that is 3. So 3 3 by 11. This is our answer. This is the square root of 1086 by 121. Question 5. Find the least number that must be subtracted from 980 so as to get a perfect square. That means 980 is not a perfect square. We are going to find the least number that must be subtracted from it to make it a perfect square. After that, we have to find the square root of this perfect number that we get. So first let's begin by the division method and try and find the square root of 980. So here let's begin by writing 980. Remember, this is a whole number. So when we pair from right to left. This is how it comes. So now we have 9 here. Let's think of 3. 3 into 3. 3 threes are 9. Minus 0. We bring down the next pair of numbers, that's 80. Now let's write the double of the quotient. Quotient is 3. Double of that is 3 into 2. 3 into 2 is 6. So that is 6 here. We need to write a number next to 6. So that we multiply by that. Now let's write 6 and next to it let's put the number 1. 61 into 1. So 61 into 1 is 61 and this is the number that we're going to write here. So next to 6 here we're going to write the digit 1. So let's write 1 here. So this becomes now 61. 61 into 1 is 61 minus, now let's subtract this and see what we get. 7, 10. 10 minus 1 is 9. 7 minus 6 is 1. We have 19. So now let's look at the remainder. The remainder is 19. That means when you subtract 19 from 980, you will get a number that is a perfect square. So let's subtract that and see. So we have 980. Now let's minus 19 from it and let's see what we get. So this is 7, 10. 10 minus 9 is 1. 7 minus 1 is 6, 9. So we've got 961. So now we found the least number that must be subtracted and we also found the number that is a perfect square when you subtract 19 from 980. Now the next part of the question is find the square root of this perfect number obtained. So we've got 961. Let's find the square root of 961. Let's use the division method again. So here we have 961. Again pair it from right to left. So we move this way. Now we have 9 there. So again 3 threes are 9 minus 9 minus 9 is 0. We bring down the next pair, that is 61. Then we double our quotient. 3 into 2 is 6. Now here next to this number 6 we're going to put a digit and multiply so that we get this number. So let's write 6 and next to it let's put 1. 61 into 1. 61 into 1 is 61. So we can use that same thing here because this is also 61. So next to 6 we're going to put the digit 1. So here we have 1 and then here 1. So 61 into 1 is 61. Now our remainder is 0. So our quotient, that is 31, is the square root of 961. So that is the answer to the second part. Find the square root of the perfect number obtained. Square root of 961 is 31. So let's write that. The square root of 961 is 31. So this is our final answer. Question 6. Find the smallest and the greatest 4-digit numbers, each of which is a perfect square. So the smallest 4-digit number which is a perfect square and the greatest 4-digit number which is a perfect square. So first let's look at the smallest. So when we're looking at the smallest 4-digit numbers which is going to become a perfect square, first let's look at the smallest 4-digit number itself. The smallest 4-digit number, as we know, is 1000. Now first we need to check to see whether 1000 itself is a perfect square. Now there are some properties of perfect squares that we have learned, isn't it? So here there is a property about the zeros. Let's count the number of zeros. 1, 2, 3. 3 zeros, that means this is not a perfect square. Remember, we learned a property which said that if the number has to be a perfect square, there should be an even number of zeros. Here we have an odd number of zeros. That means 1000 is not a perfect square. So let's divide a long division and find the square root of 1000 to help us find the smallest 4-digit number which is a perfect square. So let's begin with the division method. So we have 1000 here. Now let's pair it from right to left this way. Now we have 10. Let's look at the first pair, which is 10. Now let's look at a number which when you square it gets a number close to 10, and that is 3. So let's begin. 3 threes are 9 minus 10 minus 9 is 1. Bring down the next pair, which is 2 zeros. Now let us write the double of 3. 3 into 2 is 6. Next step, get a number next to 6 to multiply and get us a number close to 100. So now we have 6 here. Shall we think of 1 itself next to it? So 1 into 1. So we have 61 into 1, which is 61. That means that is a number closest to 100. So let's take 1 and put it next to 6 here. So we have 1. So the number has become 61 into 1, which is 61, minus. Now when we minus, we need to borrow from here. So this is 10, 9 and 10. 10 minus 1 is 9. 9 minus 6 is 3. Our remainder is 39. Now when we have a remainder, what do we do with that? We subtract it from the number given. Now this is a 4-digit number, the smallest 4-digit number. If we subtract 39 from that, we will get only a 3-digit number. So we cannot subtract. So don't look at the remainder. Now let's look at the quotient. The quotient is 31. So whenever it is addition, we look at the quotient. Here it is subtraction. So we are not looking at the remainder because we'll get a 3-digit number. So we are going to do addition and we're looking at the quotient. Now, whenever we do addition, we look at the number next to the quotient. That is, the number after 31 is 32. So the number is 32. Let's get the square of 32. 32 into 32 is 1024. So whenever we add, what do? We take this number and this number that we have got and we subtract the two, and the answer that we get, we add it to 1000. So here when you add and subtract, so first what we do is we're going to take 1024, we're going to subtract 1000 from that, and what do we get? 24. So we get 24 from it. Now to get the smallest 4-digit number, which is a perfect square, we have to add 24 to this. So when you add 24 to this, we get 1024. So you can straight away take 32 square as 1024 as the smallest 4-digit number, or you can do this addition and get 1024 as the smallest 4-digit number, which is a perfect square. So 31 square will not give you a 4-digit number, whereas 32 square will give you the smallest 4-digit number. So 1024 is the smallest 4-digit number, which is a perfect square. So let's write that answer. The smallest 4-digit perfect square number is 1024. So this is our answer. Now we have to find the greatest 4-digit number, which is a perfect square. So for that, first let's take simply the greatest 4-digit number. And which is the greatest 4-digit number? 9999. And this is not a perfect square, isn't it? Now let's find out and see. If there is a remainder, it's not a perfect square. So let's divide this and see. So we have 9999. Let's pair it from right to left. If there is a remainder after this division, that means this is not a perfect square. So now let's begin. Here we have 99. Think of a number whose square will give you a number close to 99. Now what about 9 itself? 9 nines are 81. 10 tens are 100. We can't do. So let's write 9 into 9. So 9 into 9. 9 nines are 81. Minus 9 minus 1 is 8. And 9 minus 8 is 1. Now let's bring down the next pair, 99. Next step is doubling the quotient. So 9 into 2 is 18. So let's put a number next to 18 and multiply by it to get a number close to 1899. So let's take this number 18 and let's put a digit next to it. Let's write it here. So I'm writing 18 here. Now let's put a digit next to it. Let me put 9 into 9. Now we are doing this to get a number that is going to be close to 1899. So let's see, let's multiply. 9 nines are 81, carry 8. 9 eights are 72, plus 8 is 80, carry 8. 9 ones are 9, plus 8 is 17, 1701. So here we can write that number, that is next to the number 18 we can put the digit 9 here. So let's write 9. Now it has become 189 into 9, 1701. Now let's subtract. 9 minus 1 is 8. Then we have 9. Then 8 minus 7 is 1. 198. So can you see, children, if there is a remainder, that means this number is not a perfect square. So 9999 is not a perfect square. But to find the perfect square, now we have to get a number smaller than this, isn't it? If you go to a number greater than this, it becomes a 5-digit number. So to get a smaller number, we have to subtract. And whenever you're thinking of subtraction, think of the remainder. So now we're going to subtract this number and 198. So let's write that 9999 minus 198. Now 9 minus 8 is 1. 9 minus 9 is 0. 9 minus 1 is 8. 9. Now we have 9801, and this, when you divide and see, will be a perfect square. This will not give a remainder when you do the long division method. So we have found the greatest 4-digit number, which is a perfect square. And what is that number? 9801. So the greatest 4-digit perfect square number is 9801. This is our answer. Question 7. Because the square root of 1849 is 43, find the value of these. So here, as you can see, all of them have the same digits 1849, but then the decimal point is in different places. So we have to use this value given to us and then find the answer to this. So this one, now we can write it as the square root of, now remove the points, it becomes 1849, and give it a denominator with 1 followed by how many zeros? 1, 2, 3, 4 zeros. So 1, 2, 3, 4 zeros. Now here also we do the same thing. So here we say square root of again 1849. We've removed the decimal point. We are going to write 1 followed by 1, 2. 2 zeros. And now we know the square root of this. Okay, this is already given to us. So before that, let's separate it and write separately so it gets easier for us. So 1849, the square root of that, divided by the square root of 10,000. Plus, here also we have the square root of 1849 by the square root of 100. Now we already know the square root of 1849. It's given to us in the question. It's 43. So we can write that 43 there. Now here in the denominator, we have to write the square root of 10,000. Now see the zeros. There are 4 zeros. Take one from each. So 1 followed by 1 0 there and one more 0. So that's 43 by 100. Plus, let's go to the next one. Here also 1849. We know the square root is 43. And in the denominator we have 100 and the square root of 100 is 10. So we have one pair, just take 1 0 from that. So it is 1 0, which is 10. So here we have 43 by 100 plus 43 by 10. Now convert this to a decimal number. So I can write 43 and then in my denominator there are 2 zeros. So it's divided by 2. So division means the point will move to the left. So the point is going to move 2 places to the left. And this is one place, this is the other place, it comes here. So it becomes 0.43 plus here also, let's make it a decimal number 43. Look at the denominator, there's 1 0. So there should be one decimal place. So this is one number and the point comes here, it's 4.3. So what do we have here? We have 0.43 plus 4.3. Let's add it up. So 0.43 plus 4.3. Put a 0 there just to make them like decimals. So now this is 3. 4 plus 3 is 7. 0 plus 4 is 4. So what is our final answer? Our final answer is 4.73. What have we done? We have just used the value given to us in the question and we have substituted correctly and we have got our answer. Question 7, the second one is also like that. So we have the same question and we have to solve this now. Now here this number is 1,84,900. Now we can split this up and write it this way. So we can say this is 1,849 and we can, if we multiply it by 100, we get 1,84,900, isn't it? So we have split it up into this. Now here also minus the square root of 4 into, now here 18.49, we're going to write it as 1,849. We have removed the decimal point. So we're going to show a denominator which is 1 followed by 2 zeros, because look at the question here, it's 18.49. There are 2 decimal places. That's why I put 2 zeros here. So now let's find the square root of all these and work out our answer. So here now the square root of 1,849 is given to us as 43. So let's write that separately first. 1,849 into the square root of 100 minus the square root of 4 into the square root of 1,849 by the square root of 100. So here let's write the answer. 1,849 is 43. The square root of 100, pair it up and take only one zero. So the square root of 100 is 10 minus the square root of 4 is 2. 2 into 2 is 4. So 2 into, now here we have the square root of 1,849 given to us as 43 and the square root of 100. Here we have 100 with 2 zeros. Pair up the zeros and take one zero from that. So we have 10. So now this has become 43 into 10. Let's work this out. 43 into 10 is 430 minus 2 into 43 by 10. We can convert this. We can convert this to a decimal number. So that is 2 into 43 becomes 4.3, because in the denominator we have 1 0. So the decimal point moves one place to the left and comes in between 4 and 3 and makes it 4.3. So this is 430 minus, now we have to multiply 2 into 4.3. Let's do that. 4.3 into 2. Ignore the point. 43 into 2. 2 3s are 6. 2 4s are 8. Now go back to the question and see there is one decimal place. Your answer here, that is 86, also must have one decimal place. So the point comes in between 8.6. So let's write this answer 8.6 here. So 430 minus 8.6. Now let's minus 430 minus 8.6. So here put the point here and there's a number missing. So put that there, because especially when you subtract you have to make them like decimals. Let's borrow. Now here we can't borrow from 0, so we borrow from 3. So this becomes 2, this becomes 10. From 10 we're going to borrow here. Now 10 minus 6 is 4. 9 minus 8 is 1. Then we have 2 and 4. So what is our answer here? 421.4. So this is our final answer. Question 8. The product of two numbers is 256. That means when you multiply two numbers, the answer is 256. If one number is 4 times the other number, find the numbers. So let's write the steps now. The product of two numbers is 256. One number is 4 times the other. That means the other number is x. So this one number is 4x. So this is 4x because the other number is going to be x. So one number is 4x because it's 4 times the other number, which is x. Now the product of both is 256. That means when you multiply 4x into x, you get 256. So let's work this out. This is now like an equation. 4x into x, the number is 4. X into x is x to the power of 1 plus 1, which is 2. So 4x square is 256. Now first we need to find the value of x square. That will be 256 divided by 4. How did we get division? Here it is multiplication, isn't it? 4x square means 4 into x square. So when it is multiplication and it goes to the other side, it becomes division. So here we divide that. So x square is equal to 64. 256 divided by 4 is 64. So now to find the value of x, we have to find the square root of 64. And the square root of 64, if you have learned the squares and the roots of numbers 1 to 20, you will know that the square root is 8. So now if x is equal to 8, then we should find the other number also, which is 4x. So one number is x that we have already found, so that is 8. Now the other number is 4x, that means 4 into x, which is 4 into 8. 4 8s are 32. So we have found both the numbers. One number is 32 and the other number is 8. So as you can see, this one number is 4 times this number. So that's how it's become 32 and the other number is 8. So this is our final answer. The two numbers are 32 and 8. Question 9. The area of a square plot is 2116 meters square. So consider this to be a square plot. A man takes 5 rounds of the boundary of this plot. So this is the boundary of the plot and he takes 5 rounds around the boundary. So what is inside is the area, the boundary is the perimeter. So 5 times the perimeter is the number of rounds that this man takes. Now we have to find the distance covered by him. So first step is perimeter is equal to 4 root 8. This is the formula to find perimeter when area is given. So this is in the case of a square. So when area is given and if you have to find the perimeter, this is the formula. Perimeter equals 4 into root A. So let's find that. So this is 4 into the square root of area. And what is the square root of area? It's given to us in the question. 2116 meters square. So this is 4 into, now we have to find the square root of 2116. So let's find that. So let's write down the number. We are doing the division method to find 2116. Let's pair it from right to left. We have one pair there and the other pair is 21. Now think of a number whose square will give you a number close to 21. Now you have 4 4s are 16, 5 5s are 25. You can't write 5 5s. So let's write 4 4s are 16. So 4 into 4 is 16. So let's write 16 here minus 21 minus 16 we have to do. So let's subtract here. This is 1, 11. 11 minus 6 is 5. Now we bring down the next pair, which is 16. Now we have 516. Here we have 4. Let's double the 4. So 4 2s are 8. Now here we need to put a number next to 8 so that when we multiply we get 516. So let's take 8 here and next to it let's put the number 6 into 6. 6 6s are 36, carry 3, 6 8s are 48, 49, 50, 51, 516. So next to 8 you have to put the number 6. So let's do that. Let's put 6 next to 8. So now the number is 86. 86 into 6 is 516 minus 0. So when the remainder is 0, the quotient is your answer. That means the square root of 2116 is 46. Now here we can replace that. Instead of writing square root of 2166, we have found it out to be 46. So let's write 46 here. So this is 46. So now we have to multiply 46 into 4, which is 184. So we have found the perimeter to be 184. That means one border. Now this man has taken 5 rounds. That means we have to multiply this perimeter by 5 because 5 times the perimeter. So that is 184 into 5. So this will be the distance covered by the man. So this will be the distance covered by the man. So we can write it as D. Distance is equal to 184 into 5. This is 920 and the unit is meters because in the question is given as 2116 meters square. You write meter square when it is area, but when it is perimeter you only write meter. So the distance covered by this man is 920 meters. Question 10. Find the smallest square number which is divisible by 6, 9 and 15. So we have to find a square number and that number should be divisible by all three numbers here, that is 6, 9 and 15. So what are the given numbers? The given numbers are 6, 9 and 15. So we have to find a number which is divisible by all this, isn't it? So let's find the LCM, least common multiple of all three. So let's do that. Let's find the LCM of 6, 9 and 15. Let's start with 3 itself. So that will be 3 2s are 6, 3 3s are 9, 3 5s are 15. Let's continue with 3. So we bring down 2, 3 1s are 3 and 5. Now we go to 2, 2 1s are 2, 1 and 5. Then we continue with 5, 1, 1 and 1. So what is our LCM? Our LCM is 3 into 3 into 2 into 5. Now we can break this up. 3 3s are 9 and 2 5s are 10. So 9 into 10, 9 into 10, which is 90. Okay, so the LCM is 90. Now we need to know if 90 is a perfect square. If it is a perfect square, 90 will be the smallest number which is divisible by 6, 9 and 15. Smallest square number it should be, isn't it? So 90, let's find out if it is a perfect square. Remember, when you find out if it's a perfect square, there should be no remainder or there should not be a number without a pair. So let's find out. By the prime factor method, because this is a small number, we can use the prime factor method. So now let's do that. So let's take 90 and find all the prime factors of 90. Let's begin with 2. 2 into 45 is 90. Now let's go to 5. 5 9s are 45. Let's go to 3. 3 3s are 9 and again 3 1s are 3. So what are we finding here? We're finding the square root of 90. So to find the square root of 90, we're going to write all the prime factors, that is 2, 5, 3 and 3. So let's write that 2 into 5 into 3 into 3. And what is the next step? We have to pair them up. But as you can see, 2 doesn't have a pair. 5 also doesn't have a pair. Only 3 has a pair. Only 3. So this is 2 into 5 into, we have only this pair, this one which is a pair. So now what do? We take the numbers which do not form a pair and multiply only those two, and 2 5s are 10. Now we take this LCM that we have got. This is not a square number. It's supposed to be the smallest square number, but it is not the smallest square number. So we take that number and the factors of 90 which did not form a pair. We have multiplied it by 10 and we multiplied these two, 90 into 10. That is from here. So 90 into 10 is 900. That means the smallest number which is divisible by 6, 9 and 15 is 900. So 900 is our answer. We will stop with that for now, children. In our next video, we will continue with the remaining questions. Thank you, children.